Periodic behavior refers to something that repeats over a period of time. For example, the phases of the moon. The moon cycles over and over again between a new moon, a full moon, and back to a new moon, and the cycle repeats over a period of time. During a new moon, 0% of the moon is visible to people on Earth, whereas during a full moon, 100% of the moon is visible. And halfway in between a new moon and a full moon, you have the first quarter and the last quarter. For each of those phases, 50% of the moon is visible. And this cycle repeats approximately every 30 days. So this is an example of periodic behavior, and for lots of periodic behavior, you can model it with a graph. So down here, I'm going to show you what a graph would look like for the phases of the moon. During a new moon, 0% of the moon is visible, so I'm going to put a point here. 30 days later, you're going to have another new moon. 30 days after that, you're going to have another new moon. Now, remember what I said. Halfway between new moons, you have a full moon where 100% of the moon is visible. And you'll have another full moon here. And you can see from new moon to new moon is 30 days. From full moon to full moon is 30 days. Halfway between a new moon and a full moon, you'll see 50% of the moon. Halfway between the full moon and the next new moon, you'll see 50% of the moon again. And the pattern repeats. So you can see, if I draw a smooth curve through this, I have a nice wave-looking function. And I can extend this graph for an infinite amount of time to make predictions on when the next full moon or when the next new moon is going to be. When dealing with periodic behavior, there's some terminology that you need to be familiar with. A cycle is one complete repetition of a pattern, and the period is the length of one cycle. In the case of the phases of the moon, the period was 30 days. It took 30 days for one complete cycle of the moon phases. A periodic function is a function that models periodic behavior, like the graph I drew for the phases of the moon. And the amplitude refers to the distance between the central axis of the function and the maximum or minimum. For example, if my periodic function looked something like this, this would be my central axis. It's the line over which the function alternates back and forth. So the distance between the central axis and the maximum point is my amplitude. And it's the same distance as that of the central axis to the minimum point. Those are both the same value, and that's called the amplitude.